everyone, Mrs. V here, and today we are going to talk about combination reactions and decomposition reactions from an energy perspective. Let's get our whiteboard on and let's look at exploding hydrogen. So you'll remember combination and decomposition reactions. Combination reactions are where you have two reactants and one product. So you have something like A plus B gives C. Okay, and that's combination because the two things have combined. Now, if you go the opposite way and you break something up into two parts, then that's what we call decomposition. We're going to explore today why these processes occur. And we are going to use one of my favorite reactions, and that is the reaction where you explode hydrogen. So you have probably seen this one happen, and you've got some hydrogen in a balloon, some hydrogen gas, and you're going to react it with oxygen in the air, and it's going to make water. And of course you need to balance your equation. So we've got two hydrogens on the left, two hydrogens on the right. That's okay. We've got two oxygens on the left, but only one on the right. So we're going to need to balance that by multiplying the water by 2. But now we've also upset the hydrogens. So we've got 4 hydrogens here and only 2 here. So we're going to need to double that as well. And what we see, if you can see your balloon of hydrogen here, when you ignite it with a match or with usually a candle on a stick so you can stand a long way away, you get this wonderful fireball when the hydrogen and the oxygen react. Now, this is a really exothermic reaction. Okay, you can see that it gives off light. And if you're actually in the presence of this explosion, you'll also feel some heat energy produced. And you'll also notice quite a bit of sound energy. So a lot of energy being produced by this reaction. So let's look at how a reaction produces energy. We use what's called an energy profile diagram. So here on this diagram, we have our reactants. So this is hydrogen and oxygen. And we have our products, which is water. And water is at a lower energy level. And our hydrogen and oxygen, if we come across here, is at a higher energy level. And it makes sense then that if we started with something at high energy and we ended up with something at low energy, to go from high energy to low energy, there must be some energy given off. And we see that when we do this reaction. But what about this part? For a chemical reaction to occur, the bonds in the reactants must break. And to get that started, you need to put a little bit of energy in. So here we're using the flame of the candle. or the taper if you use a taper. And that gives us some heat energy. And that's enough to just get the reaction started. So what we have is we've got 2 hydrogen molecules here and 1 oxygen molecule. Oxygen has a double bond to the next oxygen. And what we need to do is separate that into separate atoms. We need to break those bonds. When the bonds are broken, then they can recombine to form water. So up the top here, this is called the activated complex. What we're looking at in the activated complex here is this situation where all of the atoms are separated. And then as our new bonds form, as we go to, where are we, H, the new bonds form to make 2 waters. What happens here is that the bond breaking requires energy. And the bond making releases energy. Now, in this reaction, because we've gone from higher to lower energy level, we know that more energy was released. In the forming the new bonds for water than the energy needed to break the bonds of hydrogen and oxygen. And that's why we see that exothermic reaction. So here is where energy is released as the new bonds form. So we can see in this one, you only need to give it a little bit of energy and you get a lot out. And that's why overall what we see is energy given out of this reaction. Now, once you've actually broken the bonds of the first lot of hydrogen and oxygen molecules, the heat produced in the reaction will continue to break more bonds, and that's why we get this, this effect where we have a chain reaction where the energy produced with one starts another, and we end up, snowballing out of control and get this wonderful explosion. So that's why combination reactions would happen. And if you didn't get as much energy out as you put in to get a combination reaction to happen, it's not likely to happen. Because remember, lower energy means stable. And higher energy is less stable. So the reason that this combination reaction is happening is that the substances can get more stable by doing the reaction. So reaction makes the substances stable. So that's why a combination reaction happens. But what about a decomposition reaction? Because we can actually cause this reaction to go backwards. So we can take our 2 waters and we can turn them back into the 2 hydrogens and the oxygen. And we do this by electrolysis, which is where we take our water and a little bit of acid to make it conduct electricity, and we run a current, and what we actually see is that the gases are produced. And of course, we know that this one is the oxygen. There's a good colour to use, red. So this is your oxygen gas, and this is your hydrogen gas. And you know that because there's twice as much hydrogen as oxygen. And of course, makes sense, doesn't it? Water has twice as much hydrogen as oxygen. One oxygen, two hydrogens. So that makes sense. Now, what's happening here? Why would this reaction happen? You're actually making, remember, this is the less stable. This is higher energy. But of course, it won't happen naturally. When you have a glass of water, it doesn't just spontaneously break down into hydrogen and oxygen. You have to put energy in for this to happen. So the electrolysis is using electrical energy to force a reaction to happen. So this reaction does not happen naturally. So that's what you're actually doing in a decomposition reaction, is you're using energy to force the reactants, which are at low energy, to go up to high energy. But of course, you've got to put some energy in for that to occur. The other type of decomposition that we're going to look at is the decomposition of the carbonate ion. This is a thermal decomposition. We can take some copper carbonate, which is a green powder, and if we heat that, it breaks up into copper oxide, which is a black powder, and gives off carbon dioxide gas. So that's a colourless gas, so you won't see the actual carbon dioxide gas being given off. You might see the powder kind of rippling as the gas is given off, so you can see something's in there moving. So what's actually happening, if you look at the structure here of the carbonate ion, we have the carbonate ion already has a double bond to an oxygen. Now, carbon dioxide gas, the structure of that, the structure of that is an oxygen with a double bond to a carbon and then another double bond to an oxygen. So you can see we're close here. So what is actually going to happen here is this is going to form a double bond, and that means that negative won't be there. But this bond will break, and the oxygen here is going to take an extra electron, so it's going to become O2 minus. And that's when we've got copper carbonate, that's copper ions and carbonate ions. That's going to break up into the oxide ion and carbon dioxide. And then we're going to get these two making the copper oxide, which is the black powder. So that's what happens when you decompose a carbonate. So you don't always get decomposition forming elements. Sometimes decomposition can form just simpler compounds. This is a case where decomposition reaction forms simpler compounds. So here's a test for you. If I had some calcium carbonate, some marble, and I heated that, what would my products be? Pause the video, have a go, and then check back. Okay, so we know that this carbonate ion is going to break up into an oxide ion and a carbon dioxide, which means we're going to get calcium oxide when the calcium ion and the oxide ion get together, and carbon dioxide. Did you get that? Well done. Well, that is combination and decomposition, and I will see you guys in the next video.